NanoVNA is a very handy and relatively inexpensive vector network analyzer which can be used to optimize the performance of the antenna. Here we will see how the NanoVNA tracing tells us if the antenna has been optimized by the automatic antenna tuner of N7DDC design. I am checking the performance of my 80 meter center fed inverted V dipole antenna on 12 meter, which has been giving me a lot of DX in recent days. That is 7th harmonic resonance and odd harmonic. The antenna has been connected to the NanoVNA and the antenna tuner has been switched off. Stimulus frequency range has been set from 24 to 26 MHz as seen at the bottom of the NanoVNA. The yellow curve shows a dip at 25.4 MHz and the S11 indicates SWR of 1:2.25. That is suboptimal and above the 12 meter amateur radio band, which is only from 24.890 to 24.990 MHz. Here we can see that the ATU100 external antenna tuner is off and the display is inactive. Now the antenna tuner has tuned the antenna and added 0.45 microhenries of inductance and 32 picofarad of capacitance. SWR in the tuner is displayed as 0 because the radio has not been connected. Transmitting from the radio with NanoVNA on in the vicinity will damage the NanoVNA irreversibly due to the high signal strength even if from a different nearby antenna. Here the antenna has been connected only to the NanoVNA and not to the radio. The marker shows the original position at 25.4 MHz, now showing an SWR of 1:2.774, higher than the previous value of 1:2.225. I have used the marker search minimum function in the menu to find the position of minimum SWR. That can be done manually using the jog wheel on the top, though it is a bit more cumbersome. SWR is seen as 1:1.038 at 24.800 MHz, slightly below the 12 meter amateur radio band. As I do not have a manual antenna tuner, I am unable to adjust it further to exactly coincide with the narrow 12 meter amateur radio band. Still, this tuner setting has been giving me good on-band performance for 12 meter band with near 1:1 SWR being displayed in the radio while transmitting. The automatic antenna tuner in the radio was not enabled. This is the Smith chart with antenna tuner switched off. Tracing is below the center line, meaning that the antenna has mainly capacitive reactance, that is suboptimal. After switching on the tuner, we can see that the tracing is touching the 50 ohms point in the center with minimal reactive component minus J 2.092 ohms at 24.800 MHz. A well-tuned antenna should be having the Smith chart tracing at the relevant frequency touching the center of the display like this with 50 ohms impedance. That shows a well-matched antenna system for the 50 ohms impedance of the radio. We know that maximal power transfer occurs when the source and load impedance are equal. Here the source is the radio and load the antenna system.